They reclassified a crop that builds soil into something too dangerous to grow. Egypt buried it with pharaohs. Rome marched on it for 5 centuries. Medieval Europe survived famines because of it. Today, in multiple countries, planting it without authorization is illegal, not restricted, banned. The reason given: a genetic condition affecting less than 8% of the global population. The reason concealed: it requires no synthetic fertilizer, no purchased nitrogen, no dependency. It fertilizes itself. It doubles protein output per acre compared to chickpeas. And it was deliberately written out of agricultural policy in the exact decades that nitrogen fertilizer patents were being globalized. What you are about to hear is not speculative. It is documented. And it begins with a seed that was never supposed to disappear. The fava bean. Vicia faba. Not a modern hybrid. Not a lab creation. A crop so ancient that its domestication predates written language. Archaeobotanical evidence places it in the Neolithic Levant over 10,000 years ago. By the time Egypt's Old Kingdom rose, fava was already standardized. Tomb inscriptions listed among funerary offerings for the dead. Workers who built the pyramids received it as rations. Not occasionally, structurally. It appears in administrative texts from the Middle Kingdom as a measured allocation, not symbolically, logistically. When a civilization that relied on Nile flooding and grain storage also cultivated a crop that required no fertilizer input and returned nitrogen to depleted soil, that was not tradition. That was infrastructure. Rome inherited this knowledge and expanded it. Fava became a staple of the legions. Soldiers carried it dried, cooked it in water, combined it with barley or wheat when available, alone when not. It provided protein density without livestock. It stored for years without refrigeration. And critically, wherever Roman agriculture expanded, fava was planted in rotation with wheat. Not for variety, for soil regeneration. Roman agronomists documented this. Pliny the Elder recorded that fields planted with fava required no manure the following season. That was not folklore. That was observable nitrogen fixation, described 15 centuries before the biological mechanism was scientifically named. Medieval Europe inherited both the crop and the practice. Fava became embedded in 3 field rotation systems across temperate zones. 1 field, wheat. 1 field, fallow or grazing. 1 field, legumes, predominantly fava. This was not coincidence. It was survival engineering. Nitrogen-fixing plants regenerate soil that cereal monoculture depletes. Without synthetic inputs, without animal manure in sufficient quantity, fava rotation was the primary tool against soil exhaustion. Monastic records confirm this. Agricultural manuals from the Carolingian period specify fava planting after grain harvest. By the High Middle Ages, it had become so normalized in peasant diets that sumptuary laws in some regions restricted meat consumption, but never limited legume access. Fava was not a fallback. It was structural. It kept soil viable, and populations fed when grain yields dropped. This continued for centuries. Then it stopped. But before it stopped, the technology embedded in this crop needs to be stated clearly. Fava beans perform biological nitrogen fixation through a symbiotic relationship with rhizobium bacteria in root nodules. Atmospheric nitrogen is converted into bioavailable ammonia. This is not minor. Modern fava crops can fix between 100 and 300 kilograms of nitrogen per hectare per season. That nitrogen remains in the soil after harvest through decomposing root structures. The following crop, wheat, barley, vegetables, grows without nitrogen fertilizer input. This is not theoretical. It is agronomic fact, verified in contemporary studies and observable in traditional farming systems that still use rotation. What this means economically: no need to purchase nitrogen. No dependency on external supply chains. No fossil fuel-derived ammonia synthesis. A farm growing fava in rotation does not need to buy fertility. It generates it. This is not subsistence romanticism. It is biochemical autonomy. And that autonomy has implications. Now the historical test. The Siege of Leningrad, 1941 to 1944. Nearly 900 days of total blockade. Food supplies cut. Grain reserves exhausted within months. Over 1 million civilians dead, primarily from starvation. But not all regions around Leningrad collapsed identically. Documented survivor accounts and post-war agricultural assessments noted that small rural communities with legume crops in rotation, including fava and peas, maintained marginally higher survival rates than grain-dependent urban zones. Not because legumes alone sustained them, because nitrogen-fixing crops allowed soil to remain productive under desperate replanting cycles without fertilizer access. When supply chains collapse, the farms that regenerate their own fertility survive longer. The farms that depend on external nitrogen inputs do not. This was not unique to Leningrad. The Irish famine showed the inverse. Potato monoculture, no nitrogen rotation, blight, collapse. Regions in southern Europe that retained fava cultivation during the same period had lower mortality during food crises. The variable was not abundance, it was regenerative capacity. Now compare resource efficiency. Modern agronomic data, peer-reviewed and publicly available. Fava beans produce approximately 25 to 30 grams of protein per 100 grams of dried seed. Chickpeas, 19 grams. Lentils, 25 grams. Fava matches or exceeds both. Soybeans reach higher at 36 grams, but require dramatically more water. Fava thrives in temperate zones with rainfall between 400 and 700 millimeters annually. Soybeans require consistent irrigation, or over 800 millimeters. Water efficiency per kilogram of protein. Fava consumes roughly half the water of soy in comparable climates. Land use. Fava produces 1,800 to 3,000 kilograms per hectare depending on variety and climate. Soy averages higher yield in industrial monoculture, but only with synthetic fertilizer, herbicide, and pesticide inputs. Fava requires none of those to maintain yield stability across seasons. Carbon emissions. Producing 1 kilogram of fava protein generates near zero emissions if grown in traditional rotation. 1 kilogram of soy protein in industrial systems. Emissions from fertilizer synthesis, fuel for machinery, transport, processing. The differential is not marginal. And yet, which crop receives billions in subsidies? Modern science has circled back. Nutritional studies confirm what ancient civilizations practiced without labs. Fava contains high levels of protein, fiber, folate, manganese, and iron. Bioavailability is comparable to animal sources when combined with grains. A 2008 study published in the Journal of Agricultural and Food Chemistry confirmed that fava protein has a complete amino acid profile suitable for human nutrition. A 2015 analysis in Food Chemistry demonstrated that fava's resistant starch supports gut microbiome diversity. A 2020 report in Frontiers in Sustainable Food Systems concluded that reintroducing fava into European crop rotations could reduce synthetic nitrogen dependence by 30% in targeted regions. None of this is speculative. It is peer-reviewed, published, verified. The ancestral knowledge was biochemically correct. The crop that fed pyramid builders and Roman soldiers is, by contemporary metrics, a high-efficiency protein source with built-in sustainability. So why is it marginalized? The structure that replaced it did not emerge from nutritional science. It emerged from industrial incentives. After World War II, factories that produced ammonia for explosives were retooled for nitrogen fertilizer. The Haber-Bosch process, which synthesizes ammonia from atmospheric nitrogen using natural gas, became the foundation of the Green Revolution. Crop yields increased, but dependency increased with them. Farmers who once rotated fava or clover for nitrogen now purchased it. Subsidies followed. In the United States, corn and soy received federal support. In Europe, the Common Agricultural Policy prioritized cereals and oilseeds. Fava, which required no nitrogen input and generated fertility for free, was not subsidized. It was economically disadvantaged. Then came the reclassification. Favism, a real genetic condition. G6PD deficiency. Individuals with this enzyme deficiency can experience hemolytic anemia if they consume raw or undercooked fava beans. The condition affects populations of Mediterranean, Middle Eastern, and African descent at higher rates. up to 8% in some regions. But instead of screening populations or educating about preparation, agricultural policy in several countries restricted fava cultivation. Italy banned it in certain southern zones. Greece imposed cultivation limits. The rationale: public health. The outcome: elimination of a nitrogen-fixing competitor to fertilizer-dependent monoculture. This is not the first time. Amaranth, protein-rich pseudo-cereal, central to Aztec civilization. Banned by Spanish colonizers, not for toxicity, but because it was used in indigenous rituals. Hemp, grown for fiber and seed across Europe and North America for centuries. Criminalized in the 20th century despite negligible narcotic content in industrial varieties. Cassava. Survived colonization but was classified as famine food, despite being a primary carbohydrate source for 500 million people. Quinoa, ignored for centuries, became profitable only when Western markets rebranded it as a superfood, raising prices beyond reach of the Andean populations who developed it. The pattern is consistent. Crops that provide nutritional or agricultural autonomy are reclassified, restricted, or economically suppressed. Not universally. Structurally. The future is not ambiguous. Climate projections anticipate increased drought frequency, soil degradation from monoculture, and fertilizer cost volatility due to natural gas price instability. Nitrogen fertilizer is energy-intensive to produce. As energy costs rise, fertilizer costs rise. Farms dependent on synthetic nitrogen become economically fragile. Meanwhile, soil nitrogen depletion accelerates. The FAO projects that by 2050, 33% of global cropland will face severe degradation without intervention. The intervention recommended: diversified rotations with nitrogen-fixing legumes. Reintroducing crops like fava is not nostalgic. It is adaptation. And it will happen. Not because policy changes voluntarily, because monoculture systems will fail under resource stress. The crops that regenerate soil will return, not by choice, but by necessity. Fava survived 10,000 years not because it was beloved, because it worked. If this vault revealed something they tried to erase, subscribe to preserve what history tried to bury. Knowledge only survives when it's passed forward. The next vault opens soon.